Hello, everyone, and welcome to this next primer video segment. We're going to be talking about C++ memory today. So this is going to be shorter than the C memory one and a little less conceptual. So let's start out in main here. First thing I wanted to note, this is more of a strings thing, but it's worth noting here. It's kind of memory adjacent. So when we have a C++ string, these are objects. These are not char stars, though they're built around a char star. We have this, we can actually initialize this with a string literal. And the reason for that is that C++ does a lot more in the ways than C of trying to do a little bit behind the scenes for you, whether it's during compilation or whenever. It still doesn't get in your way. It doesn't do doesn't automatically do garbage collecting, obviously, but it does add some syntactic sugar. So things like this, it'll be able to tell the difference between this and saying char star stir1 equals this. And again, those are different things. Saying char star versus string is very, very different. But it will be able to figure out how to convert this to that versus char star pretty easily. Also in C++, worth noting, but cout, cout, is going to be our standard output, and endl is going to be endline. So that's we're creating this stream where we're sending in these two strings to standard output. We can also actually create these local variables with constructors. So for example, one of the string constructors is just takes in a string literal, counts char star, and converts it to a string. And this is what this one's doing. It's taking this in as a constructor. Of course, we can also do this with malloc, or more specifically, C++'s version of malloc, which is new. So instead of using malloc for anything in C++, we're usually going to end up using new. Not much of a reason not to. And then we can use this constructor here. So for example, new string, dynamic string, and it's returning a string pointer again. So new still returns a pointer, which is worth noting. And then, we can, that's printing stir3, not dstir, but still. Besides the point. One thing to note, never mix malloc and free with new and delete. This is important because I've seen people, they'll say new something or other, and then later on they'll say free that. Never do that. These are two separate systems that are not made to interact with each other. You can use malloc and free in C++ if you really want to. I wouldn't, but that's not going to cause a problem. The problem is when you mix them. So if we say new something, then we have to use delete something, and that'll be safe to do. Again, we can, again, this is a string pointer. We have to use an arrow to get to its methods, including size. We can also use this reference. So this is something that is new to C++, is we can say ampersand instead of pointer and create something called a reference. And a reference is going to, it's just syntactic sugar. Under the surface, this is still just a pointer, basically. But what it's doing is it's saying we can treat our pointer like it's a variable. This is where things like this is the term pass by reference. You're passing by one of these. And this is essentially what every object in like Java is. Java is treated all like this. It's still passed by value technically, but it's using this reference system. So by doing this, we can do like dster3.size instead of dster2 arrow size. And again, the way I did this is I just did a new string, but I dereferenced it because to get this reference, you actually just need the object itself. So yeah, you can free both of these too. And the final thing I wanted to talk about in this video is passing references through to a function. So in this case, I have this unordered map. If you program any Python, this is basically the same as a dictionary. It's just kind of more of a pain to use. But we are associating A and 2 as the key being A and the value being 2 with B and 4 and then C and 6. So unordered map, good stuff. We create the variable. Again, you'll see this is actually a local variable. We didn't use new, we just have unordered map here. We're using a constructor. And then we use that to get a reference to it, and we pass the reference over. There are times when references are a little cleaner looking. This is not one of those times. Though actually, I'm pretty sure I could just do like copy this over to here and it would be fine, but I'm not going to right now. But you see, like we pass in what looks like just an object or what looks like just a variable without any sort of pointer to it. But that isn't going to be copied over. It's actually going to be this as a pointer, basically, under the scene or under the hood. It's above, behind the scene, under the hood. Okay. So we can print that out, and it'll print out the value associated with B. Filming this right after the C memory video, if you haven't figured that out yet. CPP mem. Yeah, there we go. Nothing to make. Yeah, if you remember from our make video, this is what happens when your dependency has not been updated, which is fine because I don't think I've saved it at any point. And there we go. So it runs, it does all the things. This is from our unordered map. So I think that's it for this video. This is a pretty short one. Yeah, peace.